Hi friends, here is the solutions of question number 17 and 18 of exercise 3.2 of Matrices Chapter. Let's start. Question number 17 is as follows. We are given matrix A and I and we have to find out the value of K such that A square is equal to K A minus 2I. So for that, let us first find out the value of A square. A square is nothing but A multiplied by A. So let us do matrix multiplication. It's a 2 by 2 matrix. So when we multiply, we will get 3 3s are 9 minus 8 minus 6 plus 4, 12 minus 8 and minus 8 plus 4 again. So A square is nothing but 1 minus 2, 4 and minus 4. So now that we know the value of A square, let us substitute these values in the equation. So the equation is A square is equal to Ka minus 2I. So A square value is 1 minus 2, 4 minus 4, which is equal to K as it is. Now matrix A is 3 minus 2, 4 minus 2 minus 2 times the identity matrix. So let us solve this part further. The LHS will keep as it is. So 1 minus 2, 4 minus 4 is equal to, be very careful while we are doing the multiplication. So it will be scalar multiplication everywhere. Similarly here also, let us bring only the 2 inside friends, not the minus, because once you bring the minus it will be even more difficult. We can make lots of mistakes. So better you take only the 2 inside. So you will end up with this. So now let us solve this further. We'll get 1 minus 2, 4 minus 4. Let's do the matrix subtraction. So you'll get 3k minus 2 minus 2k, 4k minus 2 and minus 2k minus 2. So this is the final simplification. Now friends, since these two matrices are equal, what does it mean? It means that the corresponding matrix elements are going to be equal. So we can take any corresponding matrix element, like maybe the second row, second column, or the first row, second column. It's totally up to you. So for example, let me take the second row, second column. So minus 4 is equal to this particular element, which is minus 2k minus 2. So which implies I'll bring the minus 2 to the other side. So I will get this way, which implies that minus 2k is equal to minus 2, which means k is going to be equal to 1. So no matter which combination you take, whether you take first row first column or second row first column, you should get the same value of k. So just for checking, if you have time, do take another corresponding set of matrix elements. So for example, if I take the first row first column, 1 is equal to 3k minus 2. I'll just verify if what I have got is correct. So I'll bring the 2 to the other side. So I'll get 3k equal to 3, which means k is equal to 1. So whichever way I do, I'm getting k as 1. So I'm assured that my answer is correct. So this is how we solve this question. Question number 18 is as follows. You are given the matrix A as a 2 by 2 matrix, 0 minus tan alpha by 2, tan alpha by 2 and 0. And this is a to prove that question. So we have to prove that identity matrix plus A is equal to this expression on the right hand side. So friends, the first thing is we should not get overwhelmed whenever we see such a big to prove that statement. Everything can be simplified into small steps and then it will become very easy. So the first thing is we will try to start with the left hand side, because it is also going to be addition of two matrices. So the logical thing is to first do the addition. So let us start with the left hand side. Left hand side is I plus A. So identity matrix plus matrix A. So this is the left hand side actually. So when we simplify this, we'll get 1 minus tan alpha by 2, tan alpha by 2 and 1. So this is my left hand side. We can't do any further simplification. So now we'll go to the right hand side, and after solving this, we have to arrive at this expression. Then only we can prove that the left hand side is equal to the right hand side. So now let us start with the right hand side. So right hand side is this expression. While copying down, let's be very careful. Again, while copying these signs and all, we should be very careful. So, what is the first logical step? Let us do this particular subtraction. So, 1, 0, 0, 1 minus, so it will be 0 minus tan alpha by 2, tan alpha by 2 and 0. Keep the bracket sign, and this is cos alpha. So first thing is we have to do the matrix subtraction, friends, because there is a bracket sign. So if you cannot multiply matrix A with this matrix, you will get an incorrect value. So first we have to do this matrix subtraction. So let us do that. We'll get 1 tan alpha by 2, because minus and minus is there, it will become plus. 0 minus tan alpha by 2, so you'll get minus tan alpha by 2, and this will be 1 minus 0, which is 1. So this is the matrix which I get multiplied by. So this has become one matrix. Now it is multiplied by cos alpha minus sin alpha and cos alpha. So now again it is a straightforward matrix multiplication. So let us do that. So you'll get 1 into cos alpha plus tan alpha by 2 sin alpha. This is the first entry. Then 1 into minus sin alpha plus tan alpha by 2 cos alpha. Now we'll go to the second row. We'll get minus tan alpha by 2 cos alpha plus sin alpha. Then you will get tan alpha by 2, this one, tan alpha by 2 into sin alpha plus cos alpha. So friends, what do we do now? Now there is an alpha by 2 and there is alpha. So that means I cannot do any further simplification because the angles are different. Same way you can see here also the angles are different here also and here also. So now we have to use our trigonometric knowledge. There are a few formulae where you can connect alpha with its double. That is these formula. If you remember, sin 2 theta is 2 sin theta cos theta. And then you have cos 2 theta is 2 cos square theta minus 1, or it is also equal to 1 minus 2 sin square theta. If you remember, these are the formulae where an angle is related to the double of its angle. So if I have 2 theta, it will become theta on the right hand side. So in this case also, if you see, you have alpha and alpha by 2. That is, double of alpha by 2 will give you alpha. So let us start using these formulae here. So it's better. Now, do we have to convert alpha to alpha by 2 or alpha by 2 to alpha? Which is better? So if you see in the left hand side, we have to show everything in terms of alpha by 2 only. So it is better we convert everything to alpha by 2. Let us not convert anything to alpha. Okay, we have to convert to alpha by 2. So cos alpha, we have to use any of these two formula. So let us write 1 minus 2 sin square. Now half of alpha will be alpha by 2. Okay, so 1 minus 2 sin square alpha by 2 plus this I will keep as it is. Now sin alpha by 2 I can write like this, 2 sin alpha by 2 cos alpha by 2. So this is one particular expression. Now I come here, again here I can write it as alpha by 2 cos alpha by 2 plus tan alpha by 2, let me keep it as it is, into cos alpha. So cos alpha again, now here I have to take care which of these two formulas should I use. Now since I have tan alpha by 2, I will get sin alpha by 2 in the numerator and cos alpha by 2 in the denominator. So if I have a cos expression in the numerator, it will be easy for me to cancel. So it is better I use this formula of cos 2 theta. So I will write 2 cos square alpha by 2 minus 1, so that my cos term will get cancelled. Now if you're not able to understand at this stage, it is fine. As we go in the further steps, you will understand what is being done. So for now, you just accept it as it is. Now let us go to the second row. Again minus tan alpha by 2, I'll keep it as it is. Here also the same thing, cos alpha, I'll write it as 2 cos square alpha by 2 minus 1. So that my cos alpha by 2 gets cancelled. The same substitution we have to do. And finally second row second column, I'll get tan alpha by 2 into 2 sin alpha by 2 cos alpha by 2 plus, now this cos alpha you can substitute as anything, either this or this, it doesn't really make a difference. So let me write it as this particular formula. Okay, so this is my matrix. Friends, now what do we have to do? We'll keep this as it is. Here I will write it as sin alpha by 2 divided by cos alpha by 2 into 2 sin alpha by 2 into cos alpha by 2. Okay, let's be very careful whilst doing these calculations. Here again I will write it as minus 2 sin alpha by 2 cos alpha by 2 plus, now tan alpha by 2 I will write it as sin alpha by 2 divided by cos alpha by 2 into 2 cos square alpha by 2 minus 1. Okay, so this is only my first row completed. Now let us go to the second row. So that will be again minus tan alpha by 2. I will write it as sin alpha by 2 divided by cos alpha by 2, something like this, multiplied by this, I'll keep it as it is. Okay, plus 2 sin alpha by 2 cos alpha by 2. Now the last entry is going to be tan alpha by 2, I'll write it as sin alpha by 2 upon cos alpha by 2 into 2 sin alpha by 2 cos alpha by 2 plus 2 cos square alpha by 2 minus 1. So let us now cancel some terms here itself. Now if you see the first row first column element, my cos alpha by 2 will get cancelled here. Now if you go to the first row second column, you can't straight away cancel because there is a bracket here, but just keep in mind that there is a cos alpha by 2 in the numerator and denominator. Again in the second row first column, you can't do anything as of now. In the second row second column, you can cancel this cos alpha by 2. Now once the simplification is done, let us again rearrange the matrix. So this is the matrix that we get after cancelling some terms. Now let us simplify this further. So the first term, if you see, you will have 1 minus 2 sin square alpha by 2 plus 2 sin square alpha by 2. So plus and minus, it will get cancelled and you will be left with 1. So the first entry is going to be 1. Now in the first row second column, what will happen is that we have to open this bracket. So let us do that. I'll get minus 2 sin alpha by 2 cos alpha by 2 plus sin alpha by 2 upon cos alpha by 2, open the bracket, into 2 cos square alpha by 2. This is one expression, minus sin alpha by 2 upon cos alpha by 2. Okay, so this is the second entry. Now let us go to the second row. So the second row, again you will have to open the bracket. So you will get minus sin alpha by 2 upon cos alpha by 2 into 2 cos square alpha by 2 minus will become plus. So you will get sin alpha by 2 upon cos alpha by 2 plus 2 sin alpha by 2 into cos alpha by 2. So this is the third entry. Now the second row second column, again if you see, you will get 2 sin square alpha by 2 plus 2 cos square alpha by 2 minus 1. So that will be nothing but 2 of sin square alpha by 2 plus cos square alpha by 2 bracket and then minus 1. Okay, now let us see what to do further. So friends, now let us see if we can cancel some terms. If you see in the first row second column, I can cancel this cos alpha term over here. Then again you can see in the second row first column, again I can cancel this term. Okay, now if you observe, this sin square alpha by 2 plus cos square alpha by 2 will become 1. So okay, so these changes let us incorporate in the next step. So the first entry will be 1. Then after that you will get minus 2 sin alpha by 2 cos alpha by 2 plus 2 times again sin alpha by 2 cos alpha by 2 minus sine alpha by 2 divided by cos alpha by 2. Now the second row first column you will be again left with a similar term, minus sine alpha by 2 into 2 cos alpha by 2 plus sine alpha by 2 divided by cos alpha by 2 plus 2 sine alpha by 2 into cos alpha by 2. Now the second row, second column will be 2 times 1 minus 1. So now let us use this to simplify further. So you'll get 1. Now if you see in this term, what else can I do? This and this will get cancelled. See, minus 2 sine alpha by 2 cos alpha by 2 plus 2 sine alpha by 2 cos alpha by 2. So these two terms will get cancelled. Similarly here also these two terms are just the same, only the sign is different. So we can again cancel these two. So now our matrix will be reduced to 1, and then you will have minus sine alpha by 2 upon cos alpha by 2. Then in the second row first column it will be again sine alpha by 2 upon cos alpha by 2, and this will be 2 minus 1 1. So let me simplify this further. I'll get 1 minus tan alpha by 2. This is also tan alpha by 2, and this is 1. So if you check, this is what we had obtained in the left hand side of the equation. So the left hand side is equal to the, so this right hand side is equal to the left hand side, and hence we have proved this particular equation. So friends, in the next video we'll continue with the remaining questions of exercise 3.2. Till then, take care. Bye.